Hi all, welcome back. So today we are going to solve all the questions from sequence and series which came in different shifts of Jan 2025 attempt. In sequence and series we have total 16 questions, out of which 10 are easily doable and 6 are moderate, which we are going to solve. And this difficulty level is basis my perception, which may be different for others depending on their learning curve. So let's move on to our first question. Here is our first question now. Our question says if 7 is equal to this arithmetic geometric progression AGP, then we have to find the value of alpha. So first let me write the general form of infinite AGP. A plus A plus B into R plus A plus 2D into R square and going on till infinity. And this happens when mod of R is less than 1. The next formula for this infinite AGP is when magnitude of R is less than 1. Here in the question our R is 1 upon 7, which is less than 1. So the formula is S is equal to A upon 1 minus R plus D into R upon 1 minus R whole square. Now our sum is 7, sum of the whole series, and A is 5, common ratio is is 1 upon 7, and common difference is alpha. 1 minus 1 upon 7 whole square. Now we can write 1 minus 1 upon 7 whole square as 6 upon 7 into 6 upon 7, and we will multiply both sides by 1 upon 7. So 7 into 1 upon 7 will be 1 is equal to, now in the denominator it will be 5 upon 6 upon 7. So multiply by 1 upon 7, this will be 5 upon 6. Here 7 and 7 will get cancelled. Here multiplying by 1 upon 7 in this fraction, we will get plus alpha upon 36. So from here we will get alpha plus 6 times 5, 30 upon 36 is equal to 1. So we can write it alpha plus 30 is equal to 36. So from here our alpha is equal to 6. So we can see that our answer is option 2. And here we can see that our answer matches correctly. This is our next question. So this time our question says the roots of this quadratic equation are 10th and 11th term of an arithmetic progression with common difference 3 upon 2 if sum of the first 11 terms of this arithmetic progression is 88, then q minus 2p is, then we have to find the value of q minus 2p. So in this question we will use sum of first 11 terms is equal to 88. So our sum of first 11 terms is equal to 88. This will be 11 upon 2 into 2 times the first term plus n minus 1, which is 10, into common difference, which is 3 by 2, is equal to 88. Here 11 will cancel 88 8 times. So from here we will get 2a plus 15 is equal to 8 into 2 16. From here our a is equal to 1 upon 2. Now here we have the value of a. Now we can easily find the 10th term and the 11th term. So our 10th term will be a plus n minus 1, which is 9, into the common difference 3 by 2. So from here this is equal to 27 plus 1 28 upon 2. 28 upon 2 is equal to 14. And our 11th term is equal to 1 upon 2 plus 11 minus 1 10 into 3 by 2 is equal to, from here this will be 30 plus 1 31 upon 2. Here we have the 10th term and the 11th term, and these two are roots of the quadratic equation. So our sum of roots p by 3 is equal to 14 plus 31 by 2, 14 plus 31 by 2. So from here we will get 31 plus 28, 59 by 2. So our P is equal to 7 to 177 upon 2. And our Q by 3, product of roots, is 14 into 31 upon 2. 2 will cancel 14 2 times, 7 times. From here this is equal to 7 into 7 to 1, 217. So our Q is equal to 1 2 5 6. Our P is 177 upon 2 and Q is 651. Now then we have to find the value of Q minus 2P is equal to, Q minus 2P is equal to 651 minus 177 is equal to 500 minus 6, 474. From here our answer is equal to 474. And here is our solution. We can see that our answer is correct. Here is our next question. Now this time our question says, in an arithmetic progression, if S40 is equal to 1030, 1030 and the sum of 12 terms is 57, then we have to find the value of sum of 30 terms minus sum of 10 terms. So using these two relations we will find the value of A and the common difference. So first of all we will use S40 is equal to 1030. We will get 40 upon 2 into 2a plus 40 minus 1 39d 39d is equal to 1030. Here 0 will get cancelled out, 2 will cancel 4 2 times. So our 2a plus 39d is equal to 103 by 2. And let's say this is our equation number 1. Now our sum of 12 terms is equal to 57. This will be 12 upon 2 into 2a plus 12 minus 1, 11. D is equal to 57. 2 will cancel 12 6 times. From here we will get 2a plus 11d is equal to, now 6 is 3 times 2, 3 will cancel 57, 119 times divided by 2. So let's say this is our equation number 2. So we have equation number 1 and equation number 2. We will subtract equation number 2 from equation number 1. So we will get 2a will get cancelled out. 39d minus 11d will be 28. d is equal to 100 minus 16, which is 84 upon 2. 28 will cancel 84 3 times. From here we will get d is equal to 3 by 2. Our d is equal to 3 by 2. We will substitute this value in equation number 2. We will get 2a plus 33 by 2 is equal to 2a plus 33 by 2 is equal to 19 upon 2. From here 2a is equal to minus 14 upon 2. Our a is equal to minus 7 upon 2. We have value of a and d. Now our sum of 30 terms minus sum of 10 terms is equal to 30 upon 2 to a plus 30 minus 1 29d minus 10 upon 2 2a plus 10 minus 1 9 d. Now 2 will cancel 30 15 times, 2 will cancel 10 5 times. We will take 5 common. Inside we will get 3 times 2 6a minus 2a 4a plus 4a plus 87 3 times 29 minus 9. So this will be 3 times 26 8 78 15. So from here 5 times 4 times a will be minus 40 plus 78 upon 2 will be 39. Is 39 into 3 is 170. So from here this is equal to 5 into 103. This is equal to 515. From here, our option 3 is correct. And here we can see that our answer matches correctly. Here is our next question now. Now this time our question says, here we have a GP of increasing positive terms. If A1 into A5 is equal to 28 and A2 plus A4 is equal to 29, then A6 is equal to, then we have to find the value of A6. Now A1 into A5 is equal to 28. From here we will get, now A1 is A and A5 is AR raised to power 4, where A is the first term and R is the common ratio. So we will get A square R raised to power 4 is equal to 28. Taking under root both the sides, A R square is equal to, AR square is equal to 20 root 28. Now here we have one relation. Now we will use A2 plus A4 is equal to 29. We will get AR plus AR cube is equal to 29. We will take AR square common. AR cube will be R and this will be 1 upon R is equal to 29. Now here we will use AR square. So we will get root 28 R square minus 29R. You can write 29R as minus 28R minus R and plus root 28 is equal to 0. Now from here we will get root 28R and R minus root 28, root 28R minus 1 is equal to 0. So from here R is equal to 1 upon root 28 comma root 28. Now our GP is of increasing positive terms. So if we will take R is equal to 1 upon root 28, our terms will get lesser than the previous one. So R is equal to 1 upon root 28 will be rejected and this will be accepted. From here our R is equal to root 28. If our R is equal to root 28 using this relation, our A is equal to root 28 upon 28, which is 1 upon root 28. Now our A6 is equal to AR5. This is equal to 1 upon root 28 into, you can write root 28 raised to power 5 as root 28 raised to power 4 plus, into root 28. Now root 28 and root 28 will get cancelled. Root 28 raised to power 4 is 28 square, which is 28 into 28, 4, 6, 32, 8, 3, 7, 84. 784. So from here, our option 4 is correct. And here is our solution. We can see that our answer is correct. Here is our next question now. This time our question says, if the first term of an AP is 3 and sum of its first 4 terms is equal to is equal to 1/5 of the sum of next 4 terms, then the sum of first 20 terms is equal to. So our first term is equal to 3 as given in the question. Sum of first 4 terms is equal to 1/5 of sum of next 4 terms. We can write it as sum of 8 minus sum of 4. So here our sum of 4 will be 4 upon 2. 4 upon, or first let's evaluate it. This will be 6 times S4 is equal to sum of 8 terms. So this will be 6 times 4 upon 2 into 2a plus 3d is equal to 8 upon 2. 8 upon 2 2a plus 9d. Now our a is equal to 3, so 2a will be 6. 6 and 6. Here 2 will cancel 8 4 times. 4 and 4 will get cancelled. 2 will cancel 6 3 times. So from here we will get 90. This will be 70. 8 minus 1 70. 90 minus 70, which is 2d, is equal to 6 minus 18 minus 12. Our common difference is equal to minus 6. So our sum of first 20 terms is equal to 20 upon 2. 2a is 6 plus n minus 1 19 into common difference minus 6. 2 will cancel 20 10 times. From here this is equal to 10 into, we will take 6 common, inside we will get minus 13. 6 into 18 is 810 and into 10 0 the minus sign. Minus 10 80. From here our answer is option 1. And here is our solution. We can see that our answer is correct. Here is our next question now. Our question says, let an be a sequence such that here we have 2 equations and here is the relation between an, comma, n belongs to 0, 1, 2 and so on. Then we have to find the value of this sum. So there is a special solution to solve these type of problems. We will say the above equation as this given equation is linear, homogeneous, homogeneous recursion. Now only these type of equations are linear homogeneous recursions. Suppose if here we have added a constant plus 1, then this would not be linear homogeneous recursion. So let's write our equation. 2a n plus 2. We will take all the terms to the left hand side. Minus 5a n plus 1 minus 3 plus 3a n is equal to 0. Now we will make characteristic equation of this one. So this will be 2. We will replace a n plus 2 as x square minus 5 times a n plus 1. We will replace it as x plus 3 times we will replace a n as 1 is equal to 0. This is our characteristic equation. Now let's solve this equation. This is a simple equation. Roots will be 1 comma 3 by 2. Now we can say our an is equal to alpha 3 upon 2 raised to power n plus beta 1 raised to power n. Now we will use the given two equations. A0 is equal to 0. A0 is equal to 0. So from here we will get alpha is equal to minus beta. And A1 is equal to half. From here we will get half or 3 upon 2 alpha minus alpha. You can say beta as minus alpha is equal to half. So from here alpha is equal to 1. Alpha is equal to 1, then beta is equal to minus 1. We have our values of alpha and beta. Now we can find the required sum. Sigma k is equal to 1 to 100 a k. Now this is equal to sigma k is equal to 1 to 100. Our an will be from these two 3 upon 2 raised to power n minus 1. So this will be 3 upon 2 raised to power n minus 1. From here this is equal to 3 upon 2 raised to power 100 minus 1 divided by 3 upon 2 minus 1 whole minus 1. 3 upon 2 minus 1 is half. So from here this will be 3 into this expression. Now we can say this expression is A100 minus 1. And this comes in option 2. So our option 2 is correct. And here is our solution. We can see that our answer is correct. Here is our next question now. This time our question says for positive integers n, here we have 4an is equal to this, s of n is equal to this sum, then the value of this expression is. So we have to find the value of this expression. First let's define an. 1 upon an is equal to, we can write n square plus 5n plus 6 upon 4. Our 1 upon an is equal to 4 upon n plus 2 into n plus 3. Now this is equal to, we will take 4 outside. Inside we will get 1 upon n plus 2 minus 1 upon n plus 3. Now our S of n is equal to sigma k is equal to 1 to n. A of k, or let's wait a minute. Let's change here n as k. K plus 3, k plus 2, and k plus 3, k plus 2, k, and k. Here also, above also. AK is equal to a k square 5k plus 6. So let's come back. Our S of n is equal to sigma k is equal to 1 to n, 1 upon ak, which is 4 into 1 upon k plus 2 minus 1 upon k plus 3. So this is equal to 4 into 1 upon 3 minus 1 upon 4 plus 1 upon 4 minus 1 upon 5. We are opening the sum and plus dot 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 till the last value n, 1 upon n plus 2 minus 1 upon n plus 3. Here minus 1 upon 4 and positive 1 upon 4 will get cancelled, and minus 1 upon 5 will get cancelled from the next term, and so on. Our 1 upon n plus 2 will also get cancelled. So this is equal to 4 into 1 upon 3 minus 1 upon n plus 3. So we can say that our S of n is equal to 4 upon 3 into n upon n plus 3. Now 507 into S 2025 is equal to 507 into 4 upon 3 into 2025 upon 2028. So our 4 will cancel. 4 will cancel 2028 as 5017. 507 and 507 will get cancelled. 3 will cancel 2025 as 6, 7, 5. So our answer is option 2. And here is our solution. We can see that our answer is correct. This is our next question now. This time our question says the interior angles of a polygon with n sides are in AP with common difference 6 degrees. If the largest interior angle of the polygon is 219 degrees, then we have to find the value of n. So here we will equate sum of all interior angles. Sum of all interior angles will be, now number of sides are n, so the sum of all interior angles will be n upon 2, first term a plus n minus 1, common difference 6 degrees, is equal to, now the sum of all interior angles, there is a formula, n minus 2 into 180 degrees. So let's equate. We will get an plus 3n square minus 3n is equal to 180n minus 360. Now let's use the largest interior angle is 219 degree. So a plus n minus 1 into 6 is equal to 219 degrees. From here, a is equal to 225 degrees minus 6n. Now we will substitute the value of a here and above in the equation. We will get 225n minus 6n square plus 3n square minus 3n is equal to 180n minus 360. From here, we will get 3n square. We are taking terms to the right hand side. 3n square and 2 to 2 minus 180 minus 1 constant, so minus 360 is equal to 0. We have to find the value of n. Sorry. Let me check it again. I am making some mistake. 125 minus 80 and 105 minus 60. 5 42 minus 42 and minus 42 and let's move on. N square minus 14n minus 1 to 0 is equal to 0. So our n is equal to 20 and 6 minus 6 and positive 2. Product of roots is minus 120 and sum of roots is 14. Yes, it's correct. Our n should be greater than 0 because n is the number of sides. Minus 6 rejected, 20 accepted. So our n is equal to 20. So from here our answer is equal to 20. And here is our solution and we can see that our answer is correct. Here is our next question. Now our question says the number of 3-digit numbers that are divisible by 2 and 3 but not divisible by 4 and 9. So our required numbers are 3-digit numbers that are divisible by 6 minus 3-digit numbers that are divisible by 36. 4 into 9, 36, 2 into 3, 6. Now 3-digit numbers that are divisible by 6 will be 999 upon 6. These are first 999 numbers and we will subtract 2 digits from 99 upon 6. This is the greatest integer function. Minus of 999 divided by 26 minus 9 upon 36. Here we will cancel both numerator denominator by 3. We will get 2 and 3, 3, 3. Here we will get 3, 3 and 2. Here we will divide both numerator denominator by 9. We will get 4, 1, 1, 1, 4 and 1. So from here this will be greatest integer function of 333 upon 2, 166 minus 16. This will be 27 and this will be 2. So from here we will get 150 minus 25. This is equal to 125. From here our answer is 125. And from here we can see that our answer matches correctly. Here is our next question now. This time our question says, suppose that the number of terms in an AP is 2k, k belongs to n. Sum of all odd terms of the AP is 40. Sum of all even terms is 55. And the last term of the AP exceeds the first term by 27. Then we have to find the value of k. So our sum of all odd terms will be, there are k odd terms. First term will be a, 2a, 2a, suppose that the number of odd terms 2a plus, here are odd terms, not odd numbers, 2a plus k minus 1, common difference will be 2d, is equal to 40. From here we will get k plus k minus 1d is equal to 40. And let's say this is our equation number 1. Now sum of all even terms k upon 2. First even term is a plus d plus k minus 1 to d is equal to 55. From here dd will get cancelled. We will get kd plus k square. This is ka. This is ka. This will be ka plus k square d is equal to 55. This is equation number 2. We will subtract equation number 2 from equation number 1. First we will use the third one. Last term will be a plus 2k minus 1 d exceeds the first term by 27. A and a will get cancelled. From here our d is equal to 27 upon 2k minus 1. Now we will subtract the equation 2 from equation 1. We will get ka and ka will get cancelled. We will get k square d minus kd minus k square d is equal to minus 15. These two will get cancelled. Our d is equal to 15 upon k. Now we will compare both the d's. We will get 27 upon 2k minus 1 is equal to 15 upon k. We will get 27k is equal to 30k minus 15. 3k is equal to 15. Our k is equal to 5. from here our answer is option 2. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says if this sum is equal to this expression, then we have to find the value of this limit. We can say our t of n is equal to Sn minus Sn minus 1. This is sum of n terms. This will be 2n minus 1, 2n plus 1, 2n plus 3, 2n plus 5 divided by 64 minus 2n minus 3, 2n minus 1, 2n plus 1, 2n plus 3 divided by 64. We will take 2n minus 1, 2n plus 1, 2n plus 3 common divided by 64. We will take this expression common. Inside we will get 2n plus 5, 5 minus 2n plus 3. These two will get cancelled. This bracket will be 8. So this is equal to 2n minus 1 into 2n plus 1, 2n plus 3 divided by 8. Now our required limit, let's say this limit is L. Our L is equal to limit n tends to infinity, sigma r is equal to 1 to n, 1 upon tr. So 8 upon 2n minus 1, 2n plus 1 and 2n plus 3. Now here this will be limit n tends to infinity, 8 sigma r is equal to 1 to n. We can break it as 1 upon 2n minus 1, 2n plus 1 minus 2 upon 1 upon 2n plus 1, 2n plus 3. Let me check it. Above we will get 2n plus 3 minus 2n plus 1. So we can write this expression as this with an extra 4. So we will divide by 4. So from here our limit L is equal to 2 times. Let's open this limit and the sum. We will get 1 upon 1 into 3 minus 1 upon 2 into 5, 1 into 3, 2 into 5, plus we will substitute 2, 1 upon 3 into 5, 1 upon 3 into 5, 1 upon 3 into 5, minus 1 upon 5. Please wait a minute. First we substituted 1, this will be 1 and this will be 3, this will be 3 and 5, sorry. This will be 3 into 5 and plus 3 into 5 minus 5 into 2 to 4, 7 and dot 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 till infinity. Now here terms will get cancelled out, so on, and as we go further our limit will tend to 0, and so from here our L is equal to 2 upon first remains, so 2 upon 3. From here our option 2 is correct, and Here we can see that our answer matches correctly. Here is our next question now. This time our question says Sn is the sum up to n terms if sum of the first 6 terms of an AP with first term minus p common difference as p is this expression, then the absolute difference between 20th and 15th terms of the AP is. So, first of all, we can write S of n as sigma r is equal to 1 to n, 1 upon n into n plus 1. 1 into 2, 2 into 3 and 3 into 4. Yes. So this is equal to sigma r is equal to 1 to n, 1 upon n, 1 upon n minus 1 upon n plus 1. So this is equal to 1 upon 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 plus dot till 1 upon n minus 1 upon n plus 1. So the terms will get cancelled out. From here, S of n is equal to 1 minus 1 upon n plus 1, which is n upon n plus 1. So from here, as 2025 is equal to 2025 upon 2026, and from here, or we can write it as directly, we will take 2026 to the left hand side, and under root of 2026 into as 2025 will be under root of 2025, which is 5 and 4 into 5, 45. Now, its sum of first 6 terms. The sum of first 6 terms will be 6 upon 2 minus 2p plus 5p is equal to 45. 2 will cancel 6 3 times. 3 times 3, 9. P is equal to 45. From here, our P is equal to 5. So we have our value of P. So our 20th term minus 15th term is equal to A plus 19B minus A minus 14B. So A and A will get cancelled out. This is equal to 5B, which is equal to 5 times P, and this is equal to 25. From here, our answer is option 4. And here is our solution, and we can see that our answer is correct. Here is our next question now. This time our question says let TR be the rth term of an AP for some m. Our Tm is equal to 1 upon 25. This equation, and we have this sum is equal to 13. Then we have to find the value of this expression. Now, our Tm is equal to 1 upon 25. From here, we will get A plus m minus 1d is equal to 1 upon 25. And T25 is equal to 1 upon 20. From here we will get A plus 24B is equal to 1 upon 20. Now let's move on to our sum. 20 times sigma r is equal to 1 to 25 TR. Now we can write the sum as, from here our first term is A. This will be 20 into 25 upon 2 into the first term. First term is A and the 25th term, which is 1 upon 20, is equal to 13. Now from here we will find the value of A. A is equal to 13 upon 250 minus 1 upon 20. This will be 2500 and 500. Please read on it. 26 minus 25 into 25. So this will be, yes, this is equal to, from here our A is equal to 1 upon 500. 26 minus 25 upon 500. So we have our value of A now. So we will use this relation to find the value of D. So we will use this relation. 24B is equal to 1 upon 20 minus 1 upon 500, 1 upon 500. So from here this is equal to, 1 upon 20 minus 1 upon 500, 25, 25, 24 upon 500. So from here our D is also 1 upon 500. Our A is this and D is this. Our TR is, or let's write TM is equal to A plus M minus 1 into B is equal to 1 upon 25. 20 and 20 will get M is equal to 20. M is equal to 20, yes. Our M is equal to 20. Now our 5 times 20 will be 100. Sigma R is equal to 20 to 40. We can write term of R as, we will add these two. It will be R upon 500. So from here this will be 1 upon 5 into sum of first 40 terms, 40 into 41 upon 2 minus sum of 20 terms, or sum of 19 terms, sorry, because it is starting from 20. 19 into 20 upon 2. Here 2 will cancel 41 20 times, 2 will cancel 20 10 times. Here we will get 820 minus 119. So from here this will be 630 upon 5. So So this is equal to 120. 120. Please wait a minute. 630 upon 5. So this will be 1, 2, 122. There is a problem. 126. So from here, our option 2 is correct. And here is our solution, and we can see that our answer is correct. Now here is our next question. This time our question says consider an AP of positive integers whose sum of first 3 terms is 54, sum of first 20 terms lies between 1600 and 1800. Then its 11th term is. Now sum of first 3 terms is equal to a plus d plus a plus 2d is equal to 54. This will be 3a plus 3d. So a plus d is equal to 18. Our a plus d is equal to 18. And sum of first 20 terms is equal to 20 upon 2. 2a plus 19d. 2 will cancel 20 10 times. Now, as 20 lies between 1600 and 1800. And 10 times 2a plus 19d and less than 1800. 1600 is less than 210. We will take 2a plus 2d, which will be 36. 2 times a plus d and remaining 17d. Subtract both sides by 360. We will get 1440. 170d less than 1500. 1. Please wait a minute. 360. 1240. And there will be 1440. So 124 upon 17. This will be 7 into 7, 9 into 7, 9, 4, 7, 1, 1. 119 and another. This will be 7 point something d, and the other term I think will be 17 into 8. Let me check it. 2, 4, 8, 1, 2. Please wait a minute. Sorry. This is not 1, 2, 2. Our d will be I think this will be 8 point something. Let me check it again. 2 and 5. Sorry. Yeah. Yes, it will be 8 point something. So from here our D is equal to 8. Now our D is greater than 7 point something and less than 8 point something. So our D is equal to 8. And from here our D is equal to 8. From this equation A is equal to 10. Now we can find the 11th term very easily. The 11 is equal to A plus 10p, 10 plus 80, 90. Our answer is option 1. And here is our solution, and we can see that our answer is correct. So here is our next question now. This time our question says the value of this limit is. So to find the value of the limit, first let's simplify the inside expression. Limit n tends to infinity, sigma k is equal to 1 to n. We can write the whole expression as k cube plus 6k plus 11k plus 6 minus 1 upon k plus 3 factorial. Limit n tends to infinity, sigma n is equal to 1 to k. This will be k plus 1, k plus 2, k plus 3. Let me check it again. 2k, 3k, 1k, 6k, 6k square, sorry. K square, 1, 2, 3, 6, k square, 1k cube, yes. Minus 1 upon k plus 3 factorial. From it we will get limit n tends to infinity, sigma k is equal to 1 to n. Now k plus 1, k plus 2, k plus 3 upon k plus 3 factorial. These two will get cancelled and leave k plus 2 factorial. These two will get cancelled and leave k plus 1 factorial. These two will get cancelled and leave 1 upon k factorial minus 1 upon k plus 3 factorial. So let's open. First we will open only 1 upon k factorial. 1 upon 1 factorial plus 1 upon 2 factorial plus 3 factorial plus 1 upon 4 factorial plus 1 upon 5 factorial plus 1 upon 6 factorial, so on, and minus the counting starts from 1 upon 4 factorial. For this we will put k is equal to 1, 1 plus 3, 4 plus 1 upon 5 factorial, 1 upon 6 factorial, and so on till infinity. Now here 4, 5, 6 and so on will get cancelled and these tends to infinity. So as it tends to infinity, number will get smaller and tends to 0. So let's say this is our limit L. Our L is equal to 1 upon 1 plus 1 upon 2 plus 1 upon 3. From here our L is equal to 10 upon 6. Sorry, it is 1 upon 6. 3 factorial will be 6. So from here this will be upon 6, 3 plus 1, 10 upon 6. So from here our L is equal to 5 upon 3. Our answer is option 4. And here we can see that our answer matches correctly. Here is our next question now. This time our question says, here we have an arithmetic progression such that we have this equation, then the value of this sum is equal to, we have to find the value of the sum. Now in arithmetic progression, in sum of equidistant terms are same. Equidistance from the left hand from 1. So this means that a1 plus a 2024 is equal to a5 plus a2020. Now sum of 1 plus 2024 will be same, and the numbers between a5 and this, let's move on for another. We will get p-written a5, yes, a10 plus a20 15 and equal to so on. So from here our total pairs will be 20 upon 5 will be 404 plus 2. So total pairs will be 203 pairs. We have 203 pairs. Now we can write the whole sum as 203 into a1 plus a2024 is equal to 2233. So from here a1 plus a2024 is equal to 2030,203. This is equal to 2233 upon 203. So this will be 11. Now this sum is sum of all 2024 terms in an given AP. So this will be 2024 upon 2 into first term plus last term. So this is equal to 2024 upon 2 into 11. We will cancel 2024 as 1012, 1012, 01012. This is equal to 11132. So our answer is equal to 11132. And from here we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.